So today we're going to be looking at scale factor and how to use scale factor to calculate missing lengths. So to do these questions, we need to understand what is meant by similarity because scale factor creates similar shapes. So two shapes are said to be similar if one is an enlargement or a reduction of the other. So if you've got a shape and you've enlarged it, that new shape is now similar to the original shape. So two similar shapes will have their corresponding angles will be equal, so all their angles will be equal, and their corresponding sides will be in the same ratio. So if you've enlarged a side by a certain scale factor, all other sides of that shape will be enlarged by that exact same scale factor. So let's look at a little example of an enlargement. No need to copy this down just now, we're just discussing everything to do with similarity just now. So we had this smaller shape, and you can clearly see that it's been enlarged, so it's been blown up to be this bigger shape. And we know that these are going to be similar if all their angles are the same. So this angle here and here is the same, and those ones are the same, and obviously these right angles are also the same. So all angles are the same, and the corresponding sides are in the same ratio. So what I mean by that is we know that this first side, if we're just going by the boxes, centimetre boxes, so this is 2 centimetres along. The enlarged one is 6 centimetres along. And to go from 2 to 6, you times by 3. So we've enlarged that by timesing it by 3 to get 6. And this line at the top has been enlarged the same way. So we've went from 2 boxes to 6 boxes long, meaning we've times the 2 by 3 to get 6. And also this height here is 2 boxes, and we've enlarged that to be 6 boxes as well. So each of these corresponding sides have been enlarged by the same scale factor, and we say here that the scale factor is 3 because we are timesing each side by 3. Okay, so that was an enlargement. So a reduction, here we have this larger shape, so we've got an arrow here and it's been reduced to the smaller shape. Again, these angles are all the same and the bottom right angles are the same, meaning because they all have the same angles that this is a similar shape. And let's look at the scale factor. So our larger shape, we're 2 boxes along, and it's been reduced down to only 1 box, which is half the size. So if we times 2 by 0.5, we'll get 1. This height here, we've got 3 boxes, and it's been reduced down to 1.5. Again, half of 3, so if we times it by a half, we get 1.5. And that means because we could have went around the whole shape, but just giving you an idea, because we are timesing it by a half, we're halving the size, 0.5 is our scale factor. Okay, so let's look at some more examples. So we have to produce a similar figure or similar shape to the rectangle below with a scale factor of 3. So going back, remember the scale factor is what we are timesing these sides lengths by to get our new length. So if our scale factor is 3 here, we've got, so we're going to times it by a scale factor of 3. So our length is 4, we're going to times that by 3 to get our new length. Our height is 2, we're going to times that also by 3 to get our new length. So on the height we'll get 6 and the base will get 12. And these two shapes are said to be similar. So that was an enlargement. And I would like you to pause the video here. So remember, we are going to times each of these lengths by our scale factor to get our new lengths. Can you pause the video here and enlarge this triangle by a scale factor of 2? I would sketch out a triangle. It doesn't need to be neat if you don't have a ruler to measure the lengths or anything. It's just about finding what length these sides will be on the new shape. So if you just write in the length of the new shape. So if you pause the video here. Okay, so going over the answer, we're going to times all the sides by a scale factor of 2, meaning our height is going to be 8 because 4 times 2 gives us 8. Our base is 6, 3 times 2 gives us 6, and then we can just join the other one up, but knowing the length, 5 times 2 gives us 10. So well done if you got 8, 6 and 10 around your triangle. Okay, so those were an enlargement. Let's look at an example of a reduction. So we're going to sketch out this new shape, and let's use our scale factor to figure out what each of these lengths are going to be. So here we have a height of 2 boxes. We're going to times it by our scale factor, which is a half. So we're going to half this size just to get 1 box. And then along the bottom, 1, 2, 3, 4 boxes along, we're going to times it by a half. So we're going to half 4 to get 2. So we're just going to go 2 boxes along the bottom, but we're going to do this one first. And yep, the same as 2 going up, 2 going along. So it means we're going to go 1 along. Hopefully, yep, the bottom this time going along 2. And then our height is 4. 4 times a half gives us 2. And then we can just join it up. So that is a reduction. And notice that the scale factors for our enlargements were numbers that were greater than 1. So we had 3 and 2 for those examples. And when you're dealing with a reduction, our scale factor, so what we're timesing it by, will be less than 1. In this case, we've got 0.5, also a half. Okay, let's now start to use our scale factor to work out missing sides. So here we've got 2 rectangles. We're going to first work out the scale factor, and then we are going to work out this missing length here, x. Okay, so to work out our scale factor, because we are trying to find the enlargement, we're going to take 2 matching or corresponding sides. So we're going to take the 10 and the 15. And because we're doing an enlargement, we're going to take the bigger number and divide it by the smaller number. So 15 divided by 10 to give you 1.5. So we're trying to find the missing length on this shape. So we're going to take the bigger number and divide it by its corresponding smaller number. So 15 divided by 8 to give us 1.5. And because we have a number that's bigger than 1, we are doing an enlargement. And we can see clearly that we're doing an enlargement, but this is just double checking it for us. So once we've got our scale factor, we then want to work out what height this would be. So we're going to look at the corresponding height on the smaller rectangle, so 4, and we're going to take 4 and times it by our scale factor of 1.5 to get 6 centimetres. So that missing length here is 6. Okay, a second example. We are going to calculate this missing length along the bottom, and this time we are dealing with a reduction. We're going from a bigger shape down to a smaller shape. So we're first going to work out our scale factor, and because we're going from our larger shape down to our smaller shape, and we're trying to find out the length on the smaller shape, we're going to take this smaller number and divide it by the larger number. So our scale factor, we're going to take 5 divided by its corresponding length on the larger rectangle, and that will give you 0.625. And here we have a number that is less than 1, meaning we are dealing with a reduction. Now we're going to go ahead and work out what x is. We're going to look at its corresponding length on the larger rectangle, and we're going to times that by our scale factor. So 20 times 0.625 to give us 12.5. Okay, so we are dealing with an enlargement when this scale factor is bigger than 1, and we're dealing with a reduction when this is less than 1. And then we're getting our corresponding side and multiplying this by our scale factor to get our final answer. So I've got a task for you, and here I would like you to give these a go. First calculating the scale factor and then the missing lengths. So here's our missing lengths. Be careful that this one is just on the other side compared to the other examples we've been doing. And also remember, your enlargement scale factor should be greater than 1 and your reduction scale factor should be less than 1. So use that to make sure you've got the right scale factor. So if you pause now. Okay, let's go over the answers. So first off, our first one, we're going to calculate our scale factor. And we're trying to work out an enlargement. So we're going to look at two corresponding sides. We've got 4 and 10. It's an enlargement, so we're going to take the bigger number, divide it by the smaller number to get 2.5 as our scale factor. We're then going to calculate x using its corresponding side of 3. So 3 times the scale factor will give us 7.5 centimetres, that should say. Don't forget your units. And yeah, so 7.5 centimetres, that's what x is. So well done if you got that. And yes, there's an enlargement, so make sure 2.5 is greater than 1, so we have the right scale factor. This time we're going from this larger shape down to the smaller one. So we're going to first calculate the scale factor, looking at two corresponding sides that we know. Because we're dealing with a reduction, we're going to take the smaller number, divide it by the larger number to get 0.4. We're then going to use this scale factor to figure out our missing side using its corresponding length of 10 centimetres, timesing it by our scale factor to get 4 centimetres. So really well done if you got both of those correct.